Hi guys, welcome back to my channel. Please subscribe and like. Today we're gonna think another. Well, this is another book video. I also have an animation video, but check this after watching this video. So let's begin. The reason I'm being quicker than last time is because I have school. So you have to think quickly. So yeah. No, now, let's begin. Stars in galaxies are far away. We have no chance of visiting them. Everything we know about these distant objects studying the energy or radiation they emit. We cannot see through the gamma rays, X-rays, ultraviolet radiation, infrared radiation line in the shortest wavelengths. The distance between each crest of wave at one end and the longest end at the other. The size of a wavelength range from a fraction. Each type of ray range from a fraction. Each type of wave is emitted by different objects in the event, so they can be studied by astronomers to tell us more about it. For example, gamma rays can be gamma rays are seen merging from most violent explosion in the supernova, like when two stars collide. X-ray can be emitted by exploding stars. Well, stars explode when they die. So yeah, and infrared light, which infrared light is given off by some of the coldest objects in space, such as the dusty clouds, new stars, or what. Even the light we see, known as visible light, is made out of different parts. We see these components when water droplets in the air air split sunlight to form a rainbow across the side. Red, orange, yellow, green, blue, indigo, and violet colors of a rainbow can also be seen by passing white light through a glass prisms. Astronomers use this technique to split visible light from stars into its components so they can study the chemicals make up the speed in terms of the burning of these burning balls of gas. This anyway. One second. Gallery 1. Telescope for radiation light telescope. Let me do telescope. When we gaze at the night sky, we can see thousands of stars as tiny sprinkles of light. Even with the naked eye, you can make out the movement at Earth rotate. And note their varying colors and brightness. However, in order to truly study them, we depend on telescope optical instruments which make distant objects appear much larger in space, such as stars. Galaxies are far away and are only a tiny amount of light farther from their source, making their light appear dimmer. Telescopes function like buckets for collecting the faint light, just as bigger buckets catches more rainwater. A bigger telescope gathers more light. This makes fainter catches more rainwater. A bigger telescope gathers. This makes faint modern telescope that can be 10 meters wide. Telescopes can see 4 million times fainter than those see with an unaided eye. Telescopes work in 3 steps. They collect light using a lens or is magnified. Before the 19th century, astronomers simply look at the magnified image with their eyes and made wonderful drawings of what they saw. Today, the images made by large telescopes are recorded electronically, then stored on computers for analysis. Light can also be passed through a spectroscope to learn more about the wavelengths emitted by the object. The two main types of telescopes, refractors and reflectors. Refracting telescope use lens to bend or refract light. The light enters the front lens and travels through the telescope to the eyepiece, which is magnified. Reflecting telescope use mirrors to reflect light. Light enters the telescope, bounces off a curved mirror, then is reflected off a secondary mirror, which magnifies the image. We've come a long way since astronomers used the first telescope in the 17th century to look at our moon and the nearest planets. Since the technological developments have enabled us to see farther into space, far beyond our solar system and even our galaxy. Over the past centuries, telescopes has taken a huge step forward thanks to the increasingly sophisticated cameras, detectors, spectroscopes, and computers, and the CSI is of modern telescope. The power of a telescope is mainly determined by its size and the mirrors. In some, they can be 10 meters wide. If refracting lenses become too heavy at these large sizes are not used in modern telescopes. Huge research telescope is mainly to study visible light are housed in multi-story buildings called observations, which are usually perched high on the mountain tops, which air are clean, calm, and dry. Together with dark night skies, these conditions greatly help in the possible image. The next generation of base telescope will be larger than anything that predates on them and will allow to see us objects that has never object in space that has never been seen before. One example in the European Extremely Large Telescope. One assembled, it will have a diameter of 39 meters and be able to detect both visible and infrared light, gathering 8 million times more light than the telescope used by Galileo in 6009, the year 16,009. 1609. It will detect light that has taken millions or billions or even billions of years to reach Earth. So the astronomers that use it will assist will be looking back time to the young universe. This study will answer the question about the original planets, stars, galaxies, and the universe itself. Earth is surrounded by a blanket of gases called the atmosphere, which contains the air we breathe and the shield the planets against harmful rays from the sun. Fortunately, we can see right through the atmosphere to the planets and stars beyond. When we come to study these objects in detail, the atmosphere can present some problems. Moving pockets of air obscure images taken by visible light telescopes, and the atmosphere can block out whole parts of the electromagnetic spectrum. So to obtain the clearest image of space and detect the whole electromagnetic spectrum, astronomers have to position the telescope high above the atmosphere. Astronomers began to get around this problem in 1950 by attaching telescope to large helium-filled balloon which carried the instruments up above the lower layers of air. However, it soon became clear what they really needed was free-flying telescope in orbit around Earth. During the late 1960s, several X-ray and ultraviolet telescopes to be placed in the Earth orbit. Then in between April 1990 and the new era in space exploration, each telescope was designed to examine a particular return to Earth in 2000. The 2000s observed gamma rays, the Chandra X-ray Observatory observed X-rays, the Spitzer Space Telescope observed infrared, and the Hubble Space Telescope observed visible and near ultraviolet light. After a mission in 1997, it can also detect near infrared light. The Hubble has sent back some of the most stunning images ever taken. At the forefront of the next era of space telescopes will be the James Webb Telescope, orbiting at a vantage point 1.5 million kilometers away from Earth. It will be used to see infrared vision to peer more than 13.5 million light years away into the darkness of the earliest times of the universe. Wait a second, is this the end of this? The galaxy here. We'll read anyway. Thank you for watching this video. Please subscribe and like. Please subscribe and like. We'll read gallery 2 tomorrow. Bye.